Determining the tripping time for an electronic motor circuit, or EMC, depends on several factors, including firstly the current setting, secondly motor characteristics such as inertia and inductance, thirdly system voltage and frequency, and fourthly the EMC type and its specific settings. Unfortunately, the motor's datasheet does not specify the exact tripping time. However, we can estimate it using the following formula: tripping time equals 6 times the quantity of motor time constant divided by 1.15. In this formula, the motor time constant, represented as T, is equal to inductance divided by resistance. It is important to note that the inductance and resistance values are not provided in the motor specifications. Since the inductance and resistance values are not available, we can estimate the motor time constant using typical values for similar motors. For a 1.5 kilowatt motor, a time constant of approximately 0.2 seconds is considered reasonable. Now, using the estimated time constant of 0.2 seconds, we can calculate the estimated tripping time for a current setting of 4.25 amps. Plugging the values into the formula, we get tripping time equals 6 times the quantity of 0.2 divided by 1.15, which equals approximately 1.4 seconds. Let's consider the comparison with actual current values. Firstly, with the current of 4.375 amps, the estimated tripping time would be slightly less than 1.4 seconds. This setting would provide adequate protection against overloads, but the tripping time may be too fast for normal operating conditions. Secondly, with a current of 8.5 amps, the tripping time would be approximately 2.8 seconds. This setting would allow the motor to operate with transient overloads, but it may not provide sufficient protection against sustained overloads. Based on the estimated tripping time and the desired level of protection, it is recommended to set the EMC module setting current to 4.375 amps. This setting would provide a balance between protection and flexibility in operating conditions. It is also recommended to monitor the motor current during normal operation to verify that the setting is appropriate. Remember that the tripping time is influenced by the motor's time constant, which is the ratio of its inductance to its resistance. Since these values are not provided, we use a typical time constant for a similar motor, but the actual tripping time may vary depending on the motor's specific characteristics. When selecting an EMC setting, you are balancing the need for protection against nuisance tripping. A lower current setting trips the motor faster, protecting it from overloads but potentially causing unnecessary downtime. A higher current setting allows the motor to handle transient overloads but increases the risk of damage from sustained overloads. The ideal setting depends on the application and the expected load profile. Monitoring the motor current during normal operation is important to fine-tune the EMC setting and ensure adequate protection without causing unnecessary trips. If the motor trips frequently at 4.375 amps, you might consider increasing the setting slightly, but always err on the side of caution and prioritize motor protection. Conversely, if the motor never trips, even under heavy loads, you might consider reducing the setting to provide better protection. Keep in mind that these are just estimates, and the actual tripping time may vary. You should always consult the motor's datasheet and the EMC manufacturer's instructions for specific guidance.